I heard him. All right, so the name of this show is Fireworks because it's all about how fire works. Okay? So welcome to the John Deere Adventure Theater. My name is Andy. Okay. So before we get started, I need to go over a little safety information with you. So answer a question for me. Is it ever okay to play with fire? No. Is it ever okay to play with fire?
No.
No. Fire is very dangerous, right?
Yeah.
Okay, so I don't want you to misunderstand what I'm doing up here today.
But you need to walk in it.
Don't misunderstand what I'm doing up here today. I'm not playing with fire, okay? I'm doing experiments to teach you about how fire works. Okay?
About playing.
What do you notice about me that tells you that I take fire safety seriously? Yeah, so safety goggles, right? Yep, we've got these goggles on here to protect my eyes. Come on in, find a spot. Okay. What else do you notice? What tells you that I'm serious about fire safety? Closed-toed shoes, very good, yep. Okay. What about this thing? This lab coat doesn't just make me look cool. It also is flame resistant, so it does not burn very easily. Okay. Anything else you notice maybe sitting on the ground over here that might tell you that I take fire safety seriously? Yeah, that fire extinguisher over there is not just a prop. Okay, I'm prepared to use it if necessary. Okay. We take fire safety so seriously here at the Science Center that this room was actually designed with these experiments in mind. Okay. If you want to do these experiments, I recommend you study really hard in school. Okay. Go to college, study science, or education, or something else related to science, and maybe you can work here at the Science Center, or you can work in a lab somewhere. All right, so are you ready to light some things on fire?
Yes.
Are you ready to light some things on fire?
Yeah.
All right, a couple of you are enthusiastic. All right, so I'm going to start out with this fuel source known as isopropyl alcohol. Right. So with this first experiment, I am not going to tell you how it works, because that's not actually how science works. Someone doesn't just tell the scientists, the answer that they're searching for. They have to work together, right? They have to figure it out. Okay? So that's what I want you to do during this experiment. You're welcome to talk to your neighbor, try to figure out what's going on with this experiment. Okay? So I'm going to light this fuel on fire, not surprisingly. All right, everyone ready? Bring the lights down. I got my friend Maddie up there helping me out. I got a nice little bonfire going. Kumbaya! Kumbaya! All right. You're welcome to laugh when I make jokes. All right, this is not an ordinary bonfire. This fire acts a little differently. Okay? So one might call this, actually, a fire tornado. Pretty cool, huh? So what I want you to try to figure out is what's causing this fire tornado. These fire tornadoes actually happen naturally out in forests, so trees can push around oxygen, causing these fire tornadoes to go to the tops of trees. So firefighters that fight forest fires really have to understand how these fire tornadoes work. So talk to your neighbor, try to figure out what's causing this fire tornado. You're probably thinking, well, he's spinning it. That creates the fire tornado, but it's a little more complicated than that. All right, so there are 3 ingredients to fire, to making fire. Okay, fire is referred to as combustion. Or the creation of fire is combustion. And there are 3 ingredients. Combustion is what's called a chemical reaction, which means that you are putting 2 or 3 things together and you're coming up with something new. Okay, there are 3 ingredients we need. Does anyone know one ingredient you need to make fire? What's one ingredient? Oxygen, right? We need oxygen to breathe, and fire needs it too. Okay? What else do we need? Oxygen. What do you think? Carbon? A fuel source, right? Something to burn. Okay? So we need a fuel source. We need some oxygen, and there's one more thing that we need. Ready to clap your hands together? And start rubbing your hands like that. What do you feel? Are our hands going to start on fire? No. Ooh, that was close. All right. Yeah, it would take a lot of heat to start my hands on fire. More than that. All right, so those are the 3 ingredients you need to make fire. Now you know how fire works. Thanks for coming to the show. All right, let's see in action a little bit. Talk about it. So, well, I've seen this before. This is not a fancy experiment. The match. All right, in 3, 2, or not. This matchbox is it's pretty old. Not quite up to its not quite up to lighting matches anymore. All right, so who can tell me what is our fuel source? What am I burning here? Who can tell me? Well, take a look there. What is that? What's it made out of? Wood, right? So wood is our fuel source, okay? Where's the oxygen at? Where's the oxygen at?
In the air.
It's in the air. It's all around us, right? Yeah.
Yeah.
Yeah, it's in the air, the oxygen gas that we breathe. Fire needs it, okay? What about the heat? Where did the heat come from? What do you think?
Air conditioner.
What do you think? So let me ask you, when I was rubbing my hands like that, is that kind of similar to when I struck the match? I rubbed the match, didn't I? Yeah, so we used friction to generate a little heat, okay? We got that fire going. All right, so today we are going to be doing some tests. We are going to be testing different fuel sources to make sure that they all work. We're going to be testing the 3 states of matter, really. We're going to be testing a solid fuel source, a liquid fuel source, and a gas fuel source. This first fuel source is a solid. Okay? It's called lycopodium powder. You know, I need a helper with this experiment. Somebody who can read really loudly and clearly. You know what? The text on here is just so small. I'm getting kind of old. I can't read that small print anymore. I need somebody a little younger who can come down here and read it for me. It's really important to read the package before you use something when you're doing a chemical reaction, making fire. Can someone help me? You want to come down and help me? All right. Come on down. What's your name? Mitchell. Mitchell, what does this say right here? Hazard. Yeah, hazard. What does this say? Alert. Hazard alert. Whoa. That's pretty, that sounds important, right? What about this one? Highly. Flammable. Very good work. Hazard alert. Highly flammable powder. Ooh, what about this one? This is a tricky one. Combustible. Okay. Mitchell, do you think this would be a good fuel source based on what we read here? If we wanted to make a lot of fire, it says highly flammable. Yeah, it would be. Okay. All right, let's give him a round of applause. It takes courage to come down here and speak in front of everyone. Okay. Hazard alert. Highly flammable powder. Combustible. You know what? I want to make sure that this is the good stuff. I want to make sure that they sent me some truly highly flammable powder. So I don't like getting ripped off. All right, let's test it. Let's start with a spoonful. That sounds like a good idea. All right, I should probably step back, don't you think? Are we all ready for this? Let's get this party started. In 3, 2, 1. 3, 2, 1. ABC. 1, 1, 1. Combust, explode. I want a combustion reaction. What's going on here? Why won't it start on fire? What do you think? I want it light. Help me out here. We're working through this together. Any ideas? No one has any ideas? Did I provide heat? Yes, I did. Based on what the package said, did I have a good fuel source? Yeah, based on what the package said. What's that third thing, everyone?
Friction.
Friction.
Oxygen,
No
right?
friction.
Well, in order to make a combustion reaction, all three things need to come together all at once, okay? And this powder that I have here is so finely ground, okay? Each piece of it is so small that the oxygen can't get in there, okay? It's buried under itself. Does anyone have any ideas as to how I could help this powder come in contact with the oxygen? What do you think? Throw it up into the air. Very interesting idea. Okay? Well, you know what? I'm not going to throw it up in the air and then light it on fire. I'm going to do something a little more sophisticated, but that's a good idea. You know what I'm going to do? I'm going to use this. This is called a pipette. It's going to spray it in the air, spread it out, causing it to come in contact with the oxygen in the air. And I'm going to use this right here. I call this my chicken stick. Don't worry, no chickens were harmed in the making of this stick. It's just a broom handle with a candle on the end. I call it my chicken stick because it allows me to stay away from fire when necessary. So I'm kind of a chicken. Okay? All right, let's find my shoe real quickly. So,
Not
you ready to see some real fire?
good time. Right?
A couple of you? All right. Light my chicken sticks. Get my pipette. Everyone ready for this?
Is that it? The pop
All right, let's do a
balloon.
countdown. In 3, 2, 1. All right. In 3, 2, 1. Nice. All right. In 3, 2, 1. 3, 2, 1. 1, 1, 1. All right, worked that time. All right. Thank you. So, lycopodium powder is very flammable, but it has to be spread out. So what I want you to understand, come on in, let's stop. So when you spread things out, they become more flammable. Okay? So for example, these metal tongs right here. Okay? If I held a match to them, would they light on fire?
Nope.
No. What if I chopped this metal up into tiny, tiny pieces and spread it out? Yeah, it would be very flammable. Okay? You have to spread things out to make them more flammable. All right, so we just used a solid as our fuel source. What do you say we use a liquid fuel source? So this experiment is called the whoosh bottle. Talk to your neighbor for a second about why might it be called the whoosh bottle. What do you think? Talk to your neighbor. All right, you ready to find out why? All right. There we go. All right, everyone. In 3, 2, 1. Boom! Nice. That was pretty cool. All right, should I do that again? Yeah, that was awesome. All right. In 3, 2, 1. Yeah, that was kind of cool. I'm always forgetting things back behind the curtain, though. Ta! Ha! This was just the baby push ball. This is the real push ball. I'll need to top it off with a little extra ice. All right. Ah. All right. So you think this one's maybe going to be a little bigger? Yeah.
I know.
I think so. I think it's going to be a little bigger. Yeah. All right, everyone. In 3, 2, 1. There we go. Oh, that was cool. Yeah. I've actually never seen it quite do that before. I mean, like, normally there's something kind of like that, but it never lit exactly like that. All right, should I do that again? Sure. Yeah, let's do that again. That was pretty awesome.
This time I won't walk.
In 3, 2,
I
1.
won't walk.